So, welcome to this episode of Rule Breakers podcast. I'm delighted to say that my guest today is Rick Jelliffe, all the way from many, many miles away from where I am in Australia. How are you doing, Rick?
I'm recovering from the flu, so if I start coughing, that's what's going on.
Okay, all right, no worries at all. So what I typically do with the podcast so far is I try to remember, the person I'm speaking to, when did I first meet them? I can't remember in your case, but I think it might have been a conference in the UK where I first met you face to face. Back, it was definitely in the XML years. But that's my best recollection. Somewhere maybe Cambridge or Oxford or someplace like that. So maybe we start there in the whole SGML XML thing. How did you? When did you? What was it that got you into the world of markup?
Um, I went to Japan when I was in about 1989, and I worked for a company called Uniscope, which is a technical translation company, and I was what they call a rewriter. So I'd turn badly translated English into good English. And they used softquad ROF, and the guy who ran it, a very interesting guy, Robin Masson, was starting to get interested in SGML. So I and another fellow who worked there, John Reiki, he did most of the work. We wrote a little Lisp interpreter that converted a subset, a very simplified SGML into whatever you wanted to put out. In our case, to generate ROF, TROF kinds of outputs. It's more of a proof of concept. It was a full Lisp. It was a fully featured functional language, and we sort of find a start tag. If you find a start tag in this context, do this. So limited context, but context, and it worked well. So that was 89 or so. And then I came back to Sydney, and Nick Carr at Let Systems called me up and said, come and say hello, because we're involved in SGML. So this is, I suppose, 92, something like that. And so I turned up, and at the end of it, he offered me a job. They gave me a task to try and figure out why SGML wasn't popular in Asian countries. So I spent a lot of time, looking at characters and codings and, particular requirements, and came up with some ideas that got accepted by a Chinese, Japanese, Korean document processing group standards body, which was Murata and Murata-san and, people like that. And then that fed into me going along to becoming the Australian delegate to the ISO working group for SGML, and I helped draft the Annex J, K, or whatever, the web XML changes, which were basically the additions to XML that to support Unicode better.
Right.
To a certain extent, wasn't ideal because it had to be still in the constraint of SGML, so it wasn't. But things like hexadecimal references, things like that, I think, if I remember. Right. Anyway, the thing was so painful that John Bozak then decided he should just, do XML outside ISO. And some of the things that I'd done with, especially with Gavin, or the Gavin Nichols had taken up and done, found their way to XML as the character encoding regime for XML. And I was invited to participate in that, so I was participating in XML and the changes to SGML and various things. So that's sort of my start from. That's sort of how I started into.
And where did you first come across Charles Goldfarb?
Back in those sort of, 94 or so, when I'd started to write. I think there was an SGML news group, comp.citus SGML or whatever it was. And I'd written a few things saying, here's where I think SGML needs to be fixed. Or here's where the problem is. It was basically limited to 8-bit characters. That was the basic problem, that it really didn't and it didn't really have any feasible way of allowing native language markup. So people couldn't write a tag in Japanese or whatever, which was, it's, I think, a very critical thing, that especially if you're a student, but there are words in Japanese that don't have an English equivalent. So,
Sure.
like their word for block, so, doesn't really have an exact equivalent in English. So it only makes sense for them to, use native markup for it. And SGML really couldn't support that. So then out of the blue, I got a phone call in the middle of the night from Charles Goldfarb, and he was lovely. Absolutely. He was very, very kind and encouraging and stimulating. And he said, look, if you're interested in this, why not try and make a difference and become the Australian delegate? And, he's trying to rope in more countries to, beef up the effort. But unlike some people, I think I always found Charles, I sort of got where he's coming from. The old Pope John Paul II was asked, aren't you a conservative? And he said, well, my job is to conserve. And I think that's where Goldfarb felt his job was, that, once you establish a standard, then your job is to try and, you switch over from being a revolutionary to being someone who's trying to make sure it's done right.
Right.
I mean, excuse me. I found the same thing with Schematron, of course, that are sort of, in the early days, I was welcoming, encouraging any crazy ideas and additions, but as soon as it became a standard, I suddenly, oh no, that's not that's not the way it's supposed to be.
Yeah. I always found it interesting that because his background was law, he had a particular way of thinking, which was oftentimes very different from, say, a classical computer scientist, but equally valid.
Yeah, well, I think that one of the problems was that theoretical computer science was really poor. It really didn't have the ability to describe the class of grammars that SGML was described, compilers at all, in fact. So, I often used to hear people say, SGML is a problem because it doesn't accord to it doesn't fit neatly in with one of Chomsky's categories.
Right. Context-free grammar or something.
Yeah, those kind of things. And I think, well, is that really a problem of SGML, or is it the problem of the grammars that they're not differentiated enough to describe it? Sort of putting it. I mean, the point is that once you know which class it is, then you know what you need to do to implement it. You need a stack, and whatever. But I think since then there have been serious attempts to describe SGML in the class of grammars that SGML, that can describe SGML languages. And I think it's much better than those days. The other thing that I think Charles' legal framework comes out is, I think the basic thing for understanding SGML is that it's a good technical solution to a sort of like a political economic power problem. So that the main problem that SGML solves is where you have a very powerful vendor, and, like, for instance, someone who makes, Boeing, say, and then you've got a whole lot of customers who don't have nearly the same power. And when Boeing sends out the documentation, or, I'm saying Boeing, but it could be, any of those similar, large platform providers in military aerospace or whatever, when they send out their documentation for their platform or their product, how does the recipient know if they've made them, if there's a problem, if it's processable? So the problem with it, Goldfarb's solution there was to say, okay, you have this validation, and it must be validated. If it doesn't validate, then the whole thing's rejected. And I think that's the essence of SGML, is that it's designed for this particular power imbalance.
Right.
And and you compare that, say, with JSON, where his idea is, I've got a JSON program, I want to split it up in two, so half runs on the client, half runs on the server. and I'm the programmer who writes both. So there's no power questions at all. So
Right.
the kind of situation that JSON was developed for is utterly different from the one that SGML was designed for.
Right.
You can
Right.
see something like Swagger that's coming more into this sort of the SGML situation of there needs to be publicizing what the API is, and there needs to be some way of people saying, "Oh, you're not conforming to what you
Right.
say, what we'd contracted to
Right. Right.
form."
Yeah. And
So
maybe
this sort of
contract there might be the key word, really, isn't it? It's
that's
basically
right.
contract based.
Yeah, well, I'm very influenced by that. I mean, I used to work at University of Technology in Sydney, and in the engineering department, and over in the um, computer science department at the time was a fellow called Bertram Meyer, who was making the Eiffel language, and he was a visiting professor. And I remember going to a seminar of his, very very interesting. But this programming by contract
Yeah.
idea of preconditions, postconditions, that was really one of the big inspirations for Schematron.
Okay. I didn't know
That
that. Okay.
you need to state what you need to have an executable form of stating what the interface is.
Right.
Uh, and as distinct from a pure schema language where you're just saying, make sure, give me a recipe. The trouble with grammars, I mean, I think Charles and the others who invented GML were absolutely brilliant in adopting grammars. I mean, it's a brilliant idea, and it made a lot of sense because they could do validation. They could then, do schema things where you're advertising what the structures are, and then they could hang their whole, short ref mechanism. So you could have markup minimization hanging off it, and you could have, tag emission, tag implication hanging off, all those things, and you could, have type attribution and defaulting and lots of things. So as a I think they got a lot of bang for buck out of using grammars, but I tend to think that grammars are fundamentally the wrong solution for a lot of document and schema and information related problems.
Okay.
So I think grammars are all about these two things. If you have this, then you should have that.
Right.
And not at all about why.
Right.
So if you have a date, it should have a month attribute and a year attribute and a day attribute, say. But it doesn't have any idea why you should do that, or that there's any connection between them, or that if there's another attribute called temperature, that's not connected. That there's a closer coupling between. There's closer. There's the month and day. You can't understand what the month is without the year and the day.
Right. But you can
can
understand temperature. Right.
Yeah.
Independent.
So I think and it's veering into semantics, into the semantic realm, but it's still, I think, a fundamental problem, and that's why I think XML and SGML and XML and JSON and almost all the languages are fundamentally wrong-headed, because they're all about, they're not about describing the data. And now maybe RDF goes too far into into where well, I think anyone who knows RDF knows what I mean.
Yeah, it's like particle
but
physics. It's you decompose everything into subject, predicate, object, and which is entirely doable for a whole class of data, arguably all data, but it is not a terribly useful model to think about.
That's right. And sometimes it's good enough to say these things belong together, and tie, make sure they're tied together without specifying what the nature of the relationship is, what the exact relate.
Yeah.
So that's my my current feeling is that there's the problem is the basic the normal markup languages we have, and JSON and, TOML, YAML, whatever, all the ones based on minimalism. It's a race to the bottom. It's a sort of exercise in how can we get the minimum bang per buck.
Right,
and,
right,
and they try and say, well, if we get rid of a few things that I don't need, regardless of whether some other person might need them,
yeah,
that's a way of squeezing out. That's a way of making it have a little bit less buck, and
right,
therefore bang to buck ratio look good.
yeah.
I think the better approach would be to say, well, how can you get the most bang per buck? How can you get a language that takes over as much as it can? So when you're writing a document, you really don't need a schema for data typing, for instance.
Yeah,
Lexical data typing. Why should a date format? Why should there be any way? There shouldn't be any need to have a schema to say this is a date. Recognize this as a date. It's got a clear lexical
right.
format. So that's something I've been playing with quite intensively for the last few years as well. So I've got some ideas like that. Anyway, that's
interesting. It reminds me a little bit of Invisible XML, which is I think in some ways kind of saying that for things that are drop dead easy, to identify lexically, you shouldn't have to go and explicitly express anything, because the machine can do it, basically.
Well, I mean, but it's still the same problem with the underlying data model. It's still the same elements. The problem is in the invisibility, or using regular expressions to define syntax. I mean, that's just DTDs in another form. Really, it's not a. I mean, I'm not wishing to slag off on it or anything, because everything has its use, and everything, of course, there's light bulbs to go off. That was my little light bulb going off there. What I was doing then, but the problem is the XML part of the IXML, that you still, for instance, if you think of XML, the basic thing is you've got a string, a big string. The basic thing is you've got text, and then you're annotating it with elements and attributes. When you start saying, okay, we want to send data, it means you've lost annotation. You don't, if you have an attribute if you've got your data in an attribute, you've got no way of annotating that with anything.
Right.
So you sort of gone a step backwards. So I think, or you have to start having artificial, you have to try and figure out what the difference is between an attribute and an element. And I think that's a lot of things have to be elements, because otherwise they can't have attributes.
Otherwise they can't have attributes, right?
And that's a big flaw in XML, I think, or in SGML, and let alone JSON. For instance, I worked on XBRL for a little bit.
Okay.
I worked for our prudential regulator, doing a big project, with Schematron, actually, to validate that the XBRL data contained, the right stuff that was round tripping fine. And one of the things there that they say is that, if you have money, it'll have, a scalar value, 10, and it has a unit, say euro, and it has a that occurs at a date, for instance, where so you're saying we've got 10 euros as at a certain date, and you can't, these dimensions that they have, where you don't just have single scalar values. Things have dimensions where they belong to, units of locales and other stuff, which you need to understand the quantum. Right. You 10 makes, you can say, okay, I've got a spreadsheet, and the value is 10. But unless you know how many,
10 of
how
what?
many leading zeros there are, or trailing zeros there are, or what the currency is, or what the date of valuation was, as of, the 1st of July or whatever, you can't make any sense. So no markup language or JSON or anything has any ability to say these different things cannot be separated. They form a unit.
Right.
You've got an ability to put it in a unit, to put in a structure or like a JSON object or an XML element or whatever. But you've got no way of saying these things that are in this element, these attributes or fields of this structure actually belong together to the extent that removing one makes it nonsense.
Right.
So there's this whole important level of representation. It's surely important for validation.
Sure.
That is missing.
Indeed, yeah. Well, let's come back to that one because obviously I think there's a direct connection there, obviously, with the thing that you're probably most famous for in the broader community, which is Schematron. So let's come back to that. But just on your point about grammars, one of the things that's always given me pause, as a fully paid up zealot and believer, in the value of, documents that can be validated, is the disconnect that often exists between the subject matter expert who's trying to capture content out of their brain to a computer and the concept of the top-down validation paradigm that's built into all of these grammar-based systems. Because a lot of the folks that we work with would be lawyers, accountants, and so on. They have very rigorous ways of thinking about content, but it tends not to be hierarchical. The content comes into existence in smaller units. By the time it's finished, by the time the magnum opus is finished, the 700-page contract or the entire volume of parliamentary proceedings or, whatever it is, by the time it's finished, it'll be beautifully hierarchical and parsable from top to bottom. But it didn't spend its work in progress life cycle in that form. And so, the classic SGML, XML editing tools that start by, you need to tell me what the top level element is before you can move on to, I've always struggled with that disconnect, because it's one of the things that makes it more complicated than I think it needs to be to get subject matter experts to create structured documents. Is if you just think about it from their perspective, you won't arrive at a top down left to right parser. That's for sure.
That's right. Yeah, I think the SGML was designed for streaming when memory was super expensive and you had to just process, read a few bytes in, process it, and write a few bytes out. So it's it's not. It was never designed. Goldfarb knew it was all coming, but he certainly, I don't think, ever designed it with this view that you'd have the whole document in memory.
Right.
Goldfarb was he believed this IBM thing that in the future there'd only be one document of any kind. So every document would exist in only one location, and the communications would be global, that if we wanted to access that document, we'd go to that one location. My memory is that he really didn't think that how complex it was to process something was important, because it'd only be done once, it'd all be done once at one place.
I see.
And so the document and the system would be set up at that place, and then you'd access it. And it'd have, everything you need would be located through the entities, and it would all be there. There wouldn't be any of this stuff of having to move a document onto your local machine and then work out the catalog and work out all those things. So I think he was there's a prediction of the future that a lot of in a lot of parts were right, but
right.
once memory got cheap, you could start to put things in memory. And once PCs came along, people expected to do things on their local machines that weren't really networked. And once outsourcing of typing became popular and suddenly fingers became cheap, and once fingers became cheap, the whole SGML thing, which was how to reduce the amount of explicit markup in a document, how to reduce the amount of finger work needed. So in OmniMark circles, the thing, when you're making a DTD, the goal was to try and have fewer than one character per tag.
Right.
So you'd have which the markdown people would be aware of
Sure.
that kind of imperative, but that was a strong selling point for SGML in the early
Sure.
days. But as soon as fingers became cheap,
Yeah.
and gurus became expensive, relatively expensive, of course it fell by the wayside.
Right. Yeah. It's just hard sometimes to explain to, because we're going back so far here. But I remember connecting over 300 bit per second modems.
Sure.
That
was my first job, was doing the assembler programming from 300 baud modems.
Yeah.
That's where I started out. Anyway, back to Schematron.
Back to Schematron. Yeah.
The story of Schematron is that I'd written when I was working in the when the XML group was working, I started writing a book called the SGML and XML Cookbook. Originally, it was called the SGML Cookbook, and the idea was that it would go through every DTD in the scheme, or every DTD I could find, and try and find the common patterns. So it's trying to be like a pattern book for not quite a Gang of Four style formality, but certainly a thing to express all the different kinds of things that people used. When people do bold, how do they do bold? When people do an address or a post, a postal address, how do they do that? And the idea that then, not so much for saying this is the right way, this is the only way, but more of a way that people could read the book and say, okay, that's one way of doing it. So, improving the professional knowledge of people who are making schemas. And also I put in a large section on Unicode, including a printout of all the characters, which was sort of one of the first, books to do that. Because, that was something that there was a lot of, that was a very interesting time. I got conjunctivitis during the typesetting of it, went blind. So I had to typeset it while I could only, if I had a very large screen, like I suppose for those days, a 21-inch Sun monitor, and I could blow it up to see one character at a time.
Right.
And so I think I did a really good job, apart from
Wow.
Given that, but that proved to me the viability of XML, or the generalized markup as an approach, for people with, in that case, a temporary disability, but
Right.
that it's flexible enough that you can, even someone who's blind can typeset, functionally blind at that time, could typeset a book.
Right. Right.
I had a lot of experience, and so it wasn't wasn't quite as dramatic as that, but
Right.
still.
Right.
Anyway, so I'd written this book, and the thing that came to me was a lot of disappointment about what the expressivity of DTDs. And I could see there was a real problem with what they're trying to express and how they're expressing and what you could do. And then I took a job in Taiwan at there's a government think tank called Academia Sinica, and it's like any famous Chinese can get an office there. Any famous Chinese academic, and they only do research which has no commercial benefit.
Right.
So any immediate commercial benefit. So they don't do anything to get patents. They don't do, so it's the opposite mentality of almost every other university that I've been to. It's all postgrad, all, the boss's boss had a Nobel Prize, things like that. So it's quite a respectable place. And I was they gave me a job on staff to run a project to try and figure out how to adopt XML for Chinese needs, because that is, it had 5 years working with various standards groups, and one of the Taiwanese representative on that China, Korea, Japan document processing group, Sisi Shea, he was a professor who had an offer there, and he managed to get me the job, which is super nice of him. And they were very, very, very smart, impressive people. The leader, Simon Lin, Dr. Lin, he was very, very cluey. Anyway, so they basically let me do my own thing, and they got me to join W3C as their, because they wanted someone they said, we believe that Westerners are unconsciously racist towards Asians, East Asians especially, but Asians, that whatever we say will be discounted as a niche requirement. And it's something the Japanese had fought with for a long time. That they'd been trying to, trying to get things moving on the character front for a long time, but never got any traction. And I think it was one of the advantages of me was that good English, white face, aware of the issues enough, and I was very aware the clock was ticking. That my use by date would run out, and then the time when I would be needed or useful or even appropriate, would run out. But that was so. What they wanted to do was they wanted me to find out what things are missing from XML. How do we explain it to Chinese? And I'd have to go sometimes off. I'd go give a talk to the army people, the army publishing people, because they get lots of weapon systems. And then you think, okay, they're all conscripts. They're all 18-year-old boys who haven't been to university, and you're trying to, some of them never used a computer. How do you explain to them about HTML and the separation of markup and content? It's a very, very difficult problem. And I made a whole series of little schema languages to try and figure out, different approaches. And, it's one based on notations with the idea that what a markup language really need to do is embed, specific notations. You want to be able to say, in this element, I want you to have some JavaScript. In this element, I want you to have a date, and I say date. In this element, I want you to have a URL. That the key thing was that every separate layer of information should have a different kind of markup that was that was optimized for that layer, which I still tend towards. Anyway, so I got on the XML schema working group, and was immediately, because I think they'd made some key design decisions really early, like the decision to have type derivation and to couch things in terms of derived types for complex types. I think that made perfect sense to object-oriented people, and which I was at that time. As a Java programmer, at that stage I've been doing a lot of Java, so I'm completely, I've got no, I'm not an object hater, but I think there's some decisions that were made early that were hamstring, and there's some things that were left really late. For instance, how do we support? Can this thing we've made support HTML? XHTML. That was only dealt with right at the very end, when they suddenly realized, our language can't support HTML. We need to put all these other features in. We need to tackle these other things in to support. I mean, I think it would have been better if they'd have left out documents and just done it as a schema language for transporting data around. And in effect, the space that JSON is in now, I think that would have been, a lot more, because they never really replaced DTDs because they couldn't resolve the problem of entities, of special publishing characters. How people going to type in, for that whole mob, that was still, utterly essential. I had a few things of mine put in there. So I did make a few contributions. I wasn't trying to be negative, and I was certainly incredibly impressed by how smart the people were. And you'd go to a meeting and sit next to, one day I was sitting in a meeting and the person next door to me was Peter Chen, who'd made entity relationship diagrams. You know, and you think, oh good gosh. So I started thinking, okay, what would be if this is going to be too big and too much? What's the solution? In my earliest days as a programmer, I'd worked a lot in Lisp. I got a job with Texas Instruments working on their AI hardware. So they had dedicated hardware running this Symbolics, this Explorer chip, which ran Lisp as its native machine code.
Okay.
Basically, it had a tagged architecture, and it basically, it was a Lisp-oriented instruction set, and they'd use this to make some tools like expert systems and so on. They're trying to flog them in Australia, and they needed someone to support it. And it's the tail end of the project because no one was buying, because the data capture problem was just too hard. And Australia's management style at that stage was that no one makes money by leading, we all make money by following. So they weren't going to innovate. The sales pitch was along the lines of, in America, Campbell's Soup produces all these cans, but they've only got one person who knows how to run the factory. And one engineer, and he's retiring. How we can make a system to capture all his knowledge in nice sorted data with if then else chains and an expert system. And in Australia, it's no, we don't have anyone who knows anything. We can't have an expert because we're not in an expert system because we don't even have any experts. If we want someone, we'll fly someone over from America. So I was on the very tail end of that sort of thing, and they were saying, AI and Lisp especially it will die, but it'll actually go underground. So whenever you look under the covers of things in the future, you'll see garbage collection, and you'll see lists that can grow arbitrarily, rather than fixed size arrays, and all these kind of AI kind of Lispish kind of things, which is what's happened.
Sure.
Completely correct. And so I'd got this background of, I understood expert systems, and I understood publishing, and I understood schema languages. And in the Chinese situation, when you try and explain grammars to them, when you do an XML seminar, try and explain grammars, and you say, well, in a sentence you have, an element is like a word, you've got words organized as, nouns, objects, and they'd laugh because there's no Chinese word for word, or at least most Chinese don't know the Chinese word for word.
Okay.
Because they have characters.
Right.
And what we consider a word might be one character, might be two characters, it might be four. They have characters and sort of phrases, but our concept, from having things written down in spaces of words is doesn't make any sense. It's not how they think about their language. So the project was how to make XML technology or tools or discussion in ways that are Chinese can grok well. And this idea came up. Well, perhaps the whole idea of using grammars is not appropriate. So along came Schematron, which is basically an expert system.
Were you from the get-go thinking that the XSL technology was what you were going to base Schematron on, or what order did that happen?
Well, I deliberately initially wrote it in OmniMark. My first implementation was in OmniMark, but it generated XSLT.
Okay.
So I deliberately wrote the first version, the prototype version, in a way that wouldn't put XSLT-isms in there.
Okay.
Because I wanted it to be independent of the query language.
Okay.
And I wanted to be able to be, if someone had an XPath library, but not full XSLT, say, I wanted that to be able to be integrated in. So that was the idea of the query language binding, that you'd have the language itself, which is some very simple elements. You've got a scheme which has patterns have rules have assertions, and you can have variables and a few other things. But that the expression language would be, the query language would be, could be anything. Could be anything,
Right.
that could be XPath, XSLT, RDF, people have done Squish. And I mean, quite a few people took up that idea, and it sort of was obvious. Sort of an idea that people thought was strange initially suddenly became obvious. So, tools like PDM, that Java bug finder, started to use XPaths, and then a whole lot of other tools started to use XPaths as part of their location system. So it's not. I think it's an idea as time had come, and I think a lot of other people were. But it was surprising that a lot of people didn't. But I did get some pushback saying this is not a schema language,
Right.
and because people couldn't see initially how you could write a system that then applied type to nodes.
Right.
So the idea of when a lot of people talk about type, what they're really saying is you have a node in the tree, and you've added type information to it, and you can certainly do that in Schematron. I mean, you can locate an item with a rule, and then you can have an assertion to say, something needs to be true about this, and then you can have a property to apply a property to that node, and the property could be anything. So the property could easily be, this is the type of it. So that you can do typing, type attribution in scheme. You can represent it. No software does it, but it can be represented in Schematron. It's like people are saying, oh, you can't validate content models in Schematron. Just not true, because you can turn the all the element names, all the if you have an element, you can turn all its children element names into a list, and then validate a list against a regular expression.
Right.
To say, you have to turn it, so you can take a DTD content model, turn it into a regular expression, matching the string name to the elements, and so Schematron is more powerful than grammars, because it does grammars, and so much more. Now, the reason people don't do that is because the same reason why grammars are so horrible. The error messages you get back, are done in terms of where the error is found, not where the error probably occurred.
Right.
That's Schematron's thing, where you can say, okay, if I find this error, my assertion can give me information about where it's like the problem is likely to have been found.
It was a real eye opener for me when I first saw it. I thought it was really, really clever, because it never occurred to me that you could take, a styling engine or / transformation / styling, which are obviously two parts of the same coin, XSLT, XSO, but that you could repurpose that for a whole bunch of semantic validation.
Validation is another transformation.
Yeah, exactly. It's just a really, really cool idea that you're not actually targeting a formatted output. You're targeting a report about the semantic validity of the document.
That's right.
Expressing.
So Schematron produces this SVRL XML document that has results in. I mean, that's a flaw again with XML. It doesn't have any way of annotating a document with the results of some process.
The process,
without disrupting the document. It doesn't have some a way to overlay information from some subsequent process.
Well, I've been doing this a long time. You've been doing this a long time. I'm sure you've seen lots of examples over the years of the the SGML, XML famous processing instructions being used to embed all sorts of weird and wonderful things, essentially as workarounds, for things that couldn't.
Well, that's what they're for. They're very practical.
Yeah.
In those days, and I think but they a lot of it is paperism. So like the most common processing instruction was to put a new line somewhere to force a page break.
Force a page break, yeah.
That's sort of the classic processing instruction use, and that's so it's a niche case now. I guess the other thing with Schematron that was interesting was that it used a Lisp technique. That in Lisp there's a thing called symbolic computing, because where say you want to do symbolic differentiation, you've got x squared, and you want to symbolically differentiate that to turn it into 2x. You're moving a symbol around. So one of Lisp's strengths was it could do symbolic algebra. It was quite easy. You could put a formula in, and then you could have a program that took all the little pieces and rearranged them, transformed it into, in some other form, and which is the idea that you have a program that generates a program.
Right.
So that's the for Lisp that's an really sort of a standard poster boy technique of how you do things. You generate, you have a program that generates a program.
Right.
And that's how we implement Schematron. We take a schema and convert it into an XSLT, and then we run the XSLT.
Right.
And I think that's I know some people were surprised at that because it's not the kind of thing that Java people, for instance, do. Java people don't create a Java program.
Right.
Because I think there's a compilation step and it's all a bit much. Which is why I like what's the language? Zeek has this comp time feature where you can run a whole lot of the program at compile time. To generate programs that you then run. It's like macros, but much safer.
The Lisp concept of a macro is always much more profound than say what people today think of as a macro, say in a word processor.
That's right.
Wasn't it? I mean, Lisp thing was more about like, you're essentially changing the program at runtime or changing the symbols at runtime, if I remember it correctly. Like macros meant something completely different. I remember when I first read about Lisp macros, having my head somewhat exploded.
Yeah, it depended on the Lisp. Every Lisp had its own different system, but the ones with hygienic macros, especially, you did get some that were just text replacement, and there was like CPP, like the C preprocessor. You could do all sorts of you could do brilliant things, but also disastrous things.
Indeed, yeah.
And that's another place where I think XML schemas. And then, in SGML basically is based on a macro mechanism. Entities. You have a thing that gets expanded, and they're parameterless, which is unfortunate. I think Dave Peterson tried to introduce a way of making entities parameterized, which would have been a good step forward, but it never got enough traction to take off for the SGML standard. But basically, you've got these unparameterized macros that get stuck in, and you use that for document construction. You use for special characters. You use it for locating non-SGML documents and graphics, and it's sort of this addressing mechanism that's used for everything. And in DTDs, you have a special version of it called parameter entities, which you will then use you could then construct a DTD out of. You could modularize it.
Right.
In XML schemas, they said, okay, entities are macros. Macros are bad. What we need to do is we need to have high-level constructs for everything that people use macros for. So we need to elaborate everything that people macros you use entities for, and then reconstruct that. Except we'll leave out special characters because that's too hard. That's sort of that's not a post process. That's a parser thing. So that's one of the reasons why XML schemas is so complicated, because then you need to say, well, we've got abstract base types, and
Yeah.
got abstract types and concrete types, and
Yeah. Yeah.
all this kind of thing.
Yeah.
Uh,
Yeah.
but Schematron has a macro mechanism, and it's which I put in for its abstract patterns, abstract rules, and so on. And it's sort of a semi-textual. It's not, it's elements, but then parameters are substituted. The definition is a textual definition
Yeah.
of how they're substituted, but it doesn't. The way it works out, it's pretty safe, I
Yeah.
think.
Yeah.
But that's just having a little macro mechanism allows you to solve a whole lot of construction problems without going overboard, without adding, 100 new elements, but at
Yeah.
the expense of being, not necessarily being, the first thing that people would come to people's minds if they're
Sure.
coming in. But Schematron's done really well. I've been so
Yeah,
surprised.
it's just
You know,
incredible.
um,
It's I
they
mean,
just this week they brought up the latest version of the ISO standard,
yeah,
Schematron 3.11.25, the fourth version, and
yeah,
that's
yeah,
Andrew Sales has done a great job. Very
yeah,
indefatigable, um, uh, with I think Tony Graham and David Mouse doing a lot of the work too, and that's so that adds quite a few things. XQ3 and 3.1 and XSLT 3.1 bindings and libraries um, uh, and a new thing called rule sets, which is or groups, which is the big thing that people don't expect in Schematron is that every rule in a pattern is that it's an if then else chain.
Mhm.
So if you have a pattern with a whole lot of rules, a node will match. It'll tend to match a node when you're going through the document against the first rule, and then the second rule, then the third rule, and the fourth rule. The advantage of this is that each rule can then be simpler. You can have a Bloomfield style thing where you're having coarser grain and then fine. And the big advantage is at the very end, you can have a wild card. You can have a star and say,
Um,
if a node isn't caught by anything else, here's here's a catch-all, which could be, this is a mistake. Everything's supposed to be caught, or, or whatever. But a lot of people coming in thought that, no, each rule would be, a pattern is just a collection of rules that are independent.
right.
In fact, I was looking at they took Schematron out of the libxml code, or is it libxslt code, recently in the last year or early on in the year, and I was looking at the code, and its implementation of Schematron was wrong. It didn't do the if then else chain. So, if people had got used to that and then went over to a real Schematron, a conforming Schematron, they'd been very surprised. I mean, it wasn't ISO Schematron anyway. It was a version of early Schematron. So I'm quite happy that it's out of I've got
Right.
sort of, oops, got my glasses. Yes, I'm quite happy that it's out of libxml or libxslt, whichever one it is. I think it's
Okay.
there's no drama there.
Well, it's almost it's a tribute to success of a thing, isn't it? If there are end up being variations on a thing, is
Yeah,
it's a sign that the thing itself, is
yeah,
fundamental
that's right.
and
There's
has to be.
life, and yeah, and I mean, I stepped back from it 15 years ago. I added the first standard, and then the second edition I took to the vote, but then I conked out, and so really I got involved a little bit more in discussions for this last version, but basically I haven't been much involved in it for the
Right.
last 15 years. But it's 26 years old now. 1999 was the first version,
Wow.
um, and so it
Wow.
came out before XML schemas was finalized. It only took the 300 lines of code to something that was more expressive than XML schemas. Um,
Yeah.
and Yeah, so I'm pretty proud of Schematron,
Absolutely.
but
You should
I
be.
think I think and it's been used for a lot of things, like in COVID times. Um, whenever an ambulance would be dispatched, somewhere in America, if I'm getting this right, whenever an ambulance would be dispatched, they would send details of where they're going, and it would go through Schematron schema to classify it, and you know, um, use it as a smart dispatcher.
Wow.
Um, and I
Great.
think, and there's all sorts of crazy uses. Like at one stage, all the air flights above North Europe that were checked using Schematron to make sure that nothing intersected. I don't know how they did that. I've got no idea.
Wow.
But it's and I don't know, and a lot of people, and one thing I'm happy about is that a lot of people would prototype in Schematron, and they'd get, which gave them XPaths that worked
Mm.
and clear expression of the problem in, and perhaps set up a proper workflow where you had subject matter experts having input on subject matter issues,
Mm.
and programmers doing the programming, and sort of getting that kind of synergy. So I think, and then so quite a few people do that to prototyping. Once it proved itself, then they'd say, "Oh, this is so slow," and they'd then try and implement it in some Java or
Right.
whatever that they felt would be better. I'm I think that's a very nice. Yeah, I think that's a value add. I don't feel
Yeah.
like that's a negative thing,
No,
at
no,
all.
no. Because they clarified so much of their thinking and so much of the design. And it's
Yeah,
so quick that the edit, test loop
yeah,
is just so
that's
fast.
right.
Yeah, yeah,
That's right. I mean, I probably sound like, I mean, I'm definitely in the curmudgeon class, but
yeah.
the thing that I find wrong with programming languages is and the way they're taught is this algorithmic centered approach, which is fine. No drama. No, not against, you know, algorithms. Um, I don't think they're fine in moderation. Um, but the idea of, you know, the tricky part in computing is getting the machine to talk to the human,
Right.
and which is why I love the large language model AI,
Hmm.
because it's so much about this thing of how does you know how do we get a human and a computer to talk using natural language. And I mean, the problem you know the problem that it just produces rubbish all the time is, so that's that'll that's you know not quite so good. But the part of it that's to do with you know natural language becoming the tool of interaction with a computer, I think is really great. And I think Schematron was really good for that approach. And I think whenever I look at other schema, well, for instance, in XSD they added assertions. In XML schemas they added assertions, and it's
Oh.
just a thing that says if it's just an XPath and no message.
Right.
So if this it's no better and worse than a C assert or whatever.
Right. Right.
Um, it's sort of aimed at um, it's not aimed at the schema thing of saying if you have X, you should have a Y because Z.
Yeah. Yeah. Yeah.
It's sort of a context, a rule, and a reason.
Right. Right.
It's
Right.
oh, oops, there's a dog here. We don't like dogs.
Yeah. We're out.
You know, bail out. You're not valid. Um, I think um, yeah. So I think Schematron. What I was hoping with Schematron was that it wouldn't was that it would open up the door for more language centered emphasis in programming languages.
Right.
Assertions would start to have messages that expressed
Mm.
schematic information or information all couched in terms of what was supposed to be found and the
Right.
rationale, rather than in terms of I found something wrong here.
Yeah.
And
Yeah.
that hasn't happened at all. There's a few glimmers early on. Um, there's a few languages that they started with assertions where you could add strings to them. but really it's sort of gone backwards. It's not the way language designers think, because, all the modern language designers always, they're trying to go back to C and rethink C. And
Right,
so
right.
they think they're escaping C's problems, but they're just perpetuating
Yeah.
the parts they can't see, like assertions.
Right.
You
Yeah.
know,
Yeah.
um, you know, and I mean, it's probably yeah, that's the way their brains think. They're not.
Yeah.
Some people think in terms of language. Some people think in terms of pictures. Some people think in terms of code. And um, you know, the computer language industry has become a conspiracy against those people who don't think in terms of code.
We don't think in terms
It's sort of,
of
it creates. I'm very aware in my life that a lot of disabilities are created. You
right.
know, uh, a person who's, I've got a lot of Asperger's and autism in my family, an awful lot, and you can see how, someone who'd in previous times have a perfectly fine life, someone who's quite smart, and if they had a secretary, they would be able to be really successful, but because they've been told, no, you can do everything yourself. You have a computer. Because you have a PC, you don't need a secretary. And it's so stupid. It's so, you think, the people who make these comments, have they actually ever met a human? You know, that, everyone has different abilities. And the trick is trying to mesh with people who bring out your strengths and weaknesses. I mean, I guess that's the institution of marriage, or human coupling and
Right.
families. That's the underlying reality, isn't it? Can't you sort of, you've got this biological truth staring you in the face, and yet the idea that if you have a PC, you can be a Superman or Superwoman.
Right.
I mean, you don't need anyone else. You can do it all yourself.
Yeah.
That it's sort of it's a cargo cult sort of wishful thinking
Yeah. Yeah.
mentality that drives me bananas.
Yeah.
The more I see my family members suffer because of created disabilities by technology, the more not despairing, but not angry, more saddened I am
Yeah. Yeah. Yeah.
by that. On the other hand, I'm pretty much Mr. Glass half full, so things will, suddenly out of the blue, things will get better in some areas.
Well, I
I
do.
think
I do think that comment that's very common now in the AI large language ecosystem, I guess, that idea, and it's good and bad, right? So the comment that I'm thinking of is, I can't remember who said it originally, but the cool new programming language is English.
mm,
So I like it and I don't like it, right? The part that I don't like is it's almost, here we go again with US ASCII, EBCDIC, and a kind of a very Western bias, in how we think
mm.
about it, right? Which obviously has got implications.
Oh, I don't know, because deep think, so deep seek, that's native Chinese.
True, true.
That's if you use deep seek, they're actually doing it in Chinese and translating it into English at the last minute. And that's one of the problems with it. When they're English terms that don't match the Chinese ones,
Right.
you get this Chinese whisper effect sometimes
Yeah,
that you
yeah,
don't get
yeah,
on some of the other ones. But
yeah, yeah.
it's not necessary that of course an American firm will do English first, and there's so much English data out there. I edit Wikipedia quite a lot, um, and um, and my specialties Erasmus and 15th century humanists and things like that. I'm It's a very fascinating time. The personalities are so large and the stakes are so high, and you know everyone's getting carted off by the rivals and executed and all sorts of So there's very high stakes, and they're so funny. They're just witty as anything. sometimes people say, "Oh, Wikipedia will be useless in the age of ChatGPT."
Right.
No, it's the reverse. It couldn't be more useful and essential because all these AI systems, they need to have information that isn't generated by AI.
Right. Some sort of ground
As soon
truth.
as soon as they start training on AI generated data, the quality disappears very rapidly, apparently. So to have curated something like Wikipedia where it's obvious, if you make a change, you need to be able to say, I'm making a change because it's justified by this academic paper.
Right.
So once you're an editor with more than a certain number of edits, you get given access to all the library of all the major publishers, all their publications, Cambridge and Oxford and all these things. So you can find papers and get a way to justify that
Right.
what you're saying comes from a reliable source. And and there are some editors who make their business to go around whenever anything comes from an unreliable source, just removing it. Things like Wikipedia are going to be, are more important than ever.
Right.
I don't know why governments don't fund Wikipedia more
Wikipedia. Right.
as more and more essential to the new AI age.
Indeed.
I mean, people might not be using it directly. They might be having fewer logons,
Right.
but it's being mediated by by the AIs along with lots of other information.
Right.
But it's at least it's it's a great fundamental resource.
Yeah.
So I think,
Indeed.
I mean, I'm moving city in a few weeks' time. I'm going into a country town, a little country town, and when I was looking around at the various towns and looking at YouTube videos to explain the town, and there's a YouTube video from one content creator where you could see, okay, the script is written by AI, it's read by AI, the music is AI, and all the visuals are AI. Because, all the typical things that none of the signs actually, the letters in the signs sort of start off as Latin letters and then just integrate into meaningless shapes. But one town I was going to, it said, this town is near wine country, so, that's very popular for tourists. And I said, oh, that's right. And this town has the largest art gallery in a country town. It's over 4 tennis courts in size. I think it was 4 tennis courts doesn't sound very big, but yeah, that's good. Then it said this town has the largest indoor waterfall in the southern hemisphere. And you're thinking, no, it doesn't. There's no way this is right. So this sort of, this kind of hallucination is so brilliant, so hilarious. Makes the world so much more enjoyable and entertaining.
Yeah.
And so I love the AI just for the it's got so much promise for improvement and so much present comedy.
Right.
I think it's great. I've been using it to generate code for a little while to try and figure out, and I tried, I don't know, 7 or 8 different AI systems to try and figure out what, how well they handle things. And it became so obvious that once you start to ask it to do something it's never done before,
Yeah,
they
absolutely.
pretty much all lose the plot.
Yeah, absolutely. Yeah.
And they get fixated. But if you ask them to do something that's not stealing, but, flattering, sincerely flattering some other existing source code, they're great at that.
Absolutely.
You hear people making these great claims about how good or bad it is, and it's only early days. These large language models have only been out since, what was it, 22?
Right. Right.
It's barely any time at all. In 10 years' time, can start to, make bigger, claims about things, I think.
Right.
And I think anyone who uses them, immediately, the flaws become apparent really immediately. I mean, you hear there's so many projects that people start, we're going to use AI. And immediately, when the rubber hits the road, they realize this is not giving us anything useful.
I think when all the smoke clears, obviously, as you say, it's very, very early days. 2022. There's a long road ahead, but just the core, that idea of a conversational user interface has always really intrigued me. And looking back on over my own career, all the way back to the mid '80s, trying to explain what computers were doing to other people,
Mm,
and up on whiteboard drawing pictures, trying to explain, what's going on, especially if this thing is somehow integrated with this thing, right? And
mm, yeah.
invariably, what I would do is talking to a room full of people who are not software engineers.
Mm,
I would invariably adopt a human conversational metaphor, right? I'd say, well, this thing is going to talk to this thing, it's going to ask it a question,
yeah.
it's going to get back an
Yeah. Oh,
answer,
yes.
so the entire anthropomorph, whatever that fancy word, big
Mm,
anthropomorphization.
anthropomorphized. Yeah.
That
Yeah.
I've been doing that for decades,
Mm,
knowing full well that they were just analogies and that I can't actually now go ahead and turn that into some sort of computer system. But I look forward to the day when it's not just an analogy,
mm,
and that it will actually be possible to then take that off the whiteboard, written in terms of a human conversation between entities, perhaps called agents, perhaps called something else,
mm.
and actually, make it real.
That's right. I think, um, we 100 years ago, people couldn't imagine anything like what we've got, and we can't imagine what the future is going to hold. You know,
Oh,
when I was at uni, we had to write programs on punch cards, and the reason we did that was because the lecturer said, you're the last year before we turn this machine off. I want you to be able to say in 50 years' time, I've used punch cards," which is, I
yeah.
guess that's a little bit premature, but you know, uh, I think I'll do it anyway. I'll say it anyway. Um, but we can't imagine what's going to be. So anyone who says, "Oh, AI is bad, or AI is good," or whatever, you know, we've got no idea. You know what's coming out of the blue,
No,
and
indeed.
I think as long as there are legislation and standards in place to try and push things in ways that don't cause discrimination and don't make things, don't create disabilities where there are no disabilities needed. But I don't think you can trust any of the large companies that they're going to operate for good.
Mm.
I think, you know, the free market is great as far as it goes, but it needs to have, regulation to,
Yeah.
steer it out of ways that, people who are in big companies or large consortia,
Hmm.
don't think about, and especially, you know, disabilities. I think freedom and disabilities and those kind of issues
Yeah.
are
Yeah.
yeah.
Well, one of the analogies I've been thinking about recently is, um, I remember in the early days of the discovery of, radium and the whole idea of like
Mm.
radiation. There are some things I've read that are kind of hilarious now from our current perspective in 2025, of things like radioactive material being put into toothpaste because it made your teeth whiter.
Brilliant.
And apparently some radioactive material that was used was painted onto the faces of clocks,
Yeah, sure. Yeah, yeah.
so that you could read
Watches.
them at 3 a.m.
Yeah, watches.
And
Well, when I was a boy, I remember it.
right.
Or that,
So,
the brilliant Czechoslovakian glassware, that absolutely beautiful sort of greeny, eerie green Czechoslovakian glassware that's got uranium in it and is
oh,
radioactive and you can't get
yeah.
it. It's absolutely beautiful. The color, it's amazing. But,
I didn't know that about the
oops.
glassware. But I
Yeah.
guess the essential point is that here's this amazing thing that's just been found in nature, right? So something
Mm,
we now have that we didn't have before. But initially, our understanding of what it can do for good and what it can do for
mm,
bad is not good at all, right? So we
yeah.
end up making a whole bunch of mistakes, you know. And I think that's kind of where we are with this AI stuff. It's almost as if it's like the computing equivalent of the discovery of nuclear power or something. Like, it's you can be used for amazing good things, I suspect, but it needs to come with health warnings, and it needs
Yeah.
regulatory frameworks.
Yeah. I'm not sure maybe that's a little bit dramatic. I think the physical things are a bit more, you can recover from a bad program. You can't recover from
Right.
a bad mineral. I grew up in this idyllic resort town on a banana farm, and absolutely beautiful. Surf, reef, whales is just lovely. But you couldn't drink any milk from cows in my valley because of the pesticides that had been sprayed on the bananas in years past. And so I think the chemicals have got a long half life. So I'd say an AI outage or problem. I think chances are it can be chances are if easy come easy go. I think the environmental stuff is still quite is in a different class because of the permanence of it. I mean, it's generalization. It's a silly generalization to make, I suppose. But
no, I hear you. I guess in all of these things where there's some brand new thing in the world, we always look for analogies, right? Something to map it to, and but by definition, if the thing is brand new and interesting and we've never seen it before, all analogies break down at some point.
Well, that's your basic Jesuit thing, isn't it? You learn, you go from what you know to what's better known to what's less known.
Right.
Educational strategy, I think.
Yeah. Okay, Rick, we've been talking a long time, and thank you so much for your time this morning for me, this afternoon or this evening for you. It's been a real blast. You've given me so many things to think about, and also you've named some people who I'd actually forgotten, who I'll be reaching out to do something. Hopefully get them on this podcast in the future. So thanks again for your time today, Rick.
My pleasure.